students, welcome to my third and last video on chapter 10 S block elements. In this video, I'll be dealing with a few important compounds of calcium. Let us look at calcium hydroxide, which is one of the most important compounds formed by calcium. It is commercially called slaked lime, the formula of which is CaOH twice. Okay, now let's see how it's prepared. It is prepared by adding water to quick lime, that is calcium oxide, CaO. When you add water to calcium oxide, you get slaked lime. Okay, CaOH twice. Now we move on to the properties of calcium hydroxide, slaked lime. Okay, slaked lime is a white amorphous powder. It is sparingly, that is very less soluble in water. The suspension of slaked lime, that is calcium hydroxide in water, is called milk of lime. Okay, this is very important, students. Please take a note of it. Now, if you filter this milk of lime, you get a clear solution, and that clear solution is called lime water. Okay, so technically speaking, lime water is nothing but the aqueous solution of slaked lime in water. Okay, these 2 points are very important from the exam point of view. So, give importance and learn these 2 points. Now, let's see how lime water reacts with carbon dioxide. When carbon dioxide gas is passed through lime water, which is nothing but an aqueous solution of calcium hydroxide, calcium carbonate is precipitated, and as a result, it turns milky. Okay, now what happens if you pass excess of carbon dioxide into this solution? On passing excess of carbon dioxide, the precipitates of calcium carbonate, okay, this will dissolve to form calcium hydrogen carbonate. Clear? Now let's see how milk of lime reacts with chlorine. This is an important reaction, students. Please make a note of it. Okay, what is milk of lime? Milk of lime is nothing but a suspension of calcium hydroxide. Remember? Okay, milk of lime reacts with chlorine to form calcium hypochlorite. Clear? CaOCl twice. Calcium hypochlorite is formed due to the reaction of a suspension of calcium hydroxide with chlorine. Okay, and this calcium hypochlorite is an important constituent of bleaching powder, along with the formation of small quantities of calcium chloride and 2 molecules of water as byproducts. Following are the uses of calcium hydroxide. Calcium hydroxide is used in the preparation of mortar, which is a building material. It is used in whitewashing because of its disinfectant nature. It is used in glass making and in tanning industry. Calcium hydroxide is used for the preparation of bleaching powder and also for purification of sugar. Our next topic is plaster of Paris. What is plaster of Paris? It is calcium sulfate hemihydrate. Okay, how is it prepared? It is prepared by heating gypsum, the formula of which is calcium sulfate dihydrate, to 393 Kelvin. When gypsum is heated to 393 Kelvin, it forms plaster of Paris with the removal of 3 molecules of water. Now, what are the properties of plaster of Paris? It is a white powder and it has the remarkable property of setting with water. What is setting of plaster of Paris? On mixing with sufficient quantity of water, plaster of Paris forms a plastic mass. Okay, a plastic mass is formed when you mix plaster of Paris with water, which sets into a hard solid in 5 to 10 minutes. This is called setting of plaster of Paris, and this is due to hydration of plaster of Paris. When plaster of Paris gets hydrated, it results in setting of plaster of Paris. Clear? Now, what is dead burnt plaster? Above the temperature of 393 Kelvin, plaster of Paris loses all of its water of crystallization. So, the resulting anhydrous calcium sulfate is called dead burnt plaster. Why is it called dead burnt plaster? Because it does not set in the presence of water. It is no more useful. Okay, so it is called dead burnt plaster. Next, I will move on to the uses of plaster of Paris. Plaster of Paris is used in the building material as well as plasters. It is used in surgical bandages for plastering, that is, immobilizing the affected part of organ where there is a bone fracture or sprain. Plaster of Paris is used in dentistry, in ornamental work, and for making casts of statues and busts. Cement. It is a commercially important building material. It was first introduced by Joseph Aspdin in England in the year 1824. It is also called Portland cement because it resembles with natural limestone quarried in the Isle of Portland, England. It is a product obtained by combining a material which is rich in lime, that is calcium oxide, with other materials such as clay which contains silica, that is SiO2, along with the oxides of aluminium, iron and magnesium. The average composition of Portland cement is 50 to 60% of lime, 2 to 3% of magnesium oxide, 20 to 25% of silica, 1 to 2% of ferric oxide, 5 to 10% of alumina, and 1 to 10% of sulfur trioxide. For a good quality cement, the ratio of silica to alumina should be somewhere in between 2.5 to 4, and the ratio of lime, that is calcium oxide, to the total oxides, that is silica, alumina and ferric oxide, should be close to 2. Manufacture of cement. The raw materials for the manufacture of cement are limestone and clay. When powdered lime and clay are strongly heated together, they fuse and react to form cement clinker. This clinker is then mixed with 2 to 3% by weight of gypsum, that is calcium sulfate dihydrate, to form cement, which is then powdered well. And this is called Portland cement. The following are the important ingredients of Portland cement. They are 26% of dicalcium silicate, 51% of tricalcium silicate and 11% of tricalcium aluminate. Now I will move on to setting of cement. What is setting of cement? When mixed with water, cement slowly sets into a hard mass. This is called setting of cement and it is an exothermic process. Setting of cement is due to the hydration of the molecules of the constituents of cement and their rearrangement. Now, when I was talking about the manufacture of cement, I mentioned that 2 to 3% by weight of gypsum is added or mixed with cement clinker. What exactly is the purpose of adding gypsum? Gypsum is added only to slow down the process of setting of cement so that it gets sufficiently hardened. Now, let us look at the uses of cement. Next to iron and steel, cement has become a commodity of national necessity for any country. Cement is used in concrete and reinforced concrete. It is used in plastering and in the construction of dams, bridges, and buildings. So, students, with this I wind up my last video on Chapter 10 S Block Elements. Thank you for watching and bye-bye for now.